In this video, we're going to talk about the steering or the camera block that's available on Canvas to help us do steering control. So in the steering control handout, you are going to be, you're probably at this point where you've put together your control system, and you want to be able to insert in a camera that'll then determine the angle between the direction the robot's moving and the location of a line on the ground. So if you download the camera.slx file, you can double click on it, and then here you see the camera. So you would have put together your own simulink block diagram that contains your system models for phi dot and rho dot for turning and going straight. You've got your inner control loops. You've got your set point. So here's the set point for moving forward. You have your outer control loop for angle. And the input to that control should be the error between the direction that you are currently going and the direction you want to go, right? So that's the thing that's going to be calculated by this camera block. So what you can do is you can just go over here and copy and then paste that guy in here and then put it in the right spot. I've already done that in this diagram. The elements that are going to be hooked up to it should be phi, x, y. So that's the angle and position of the robot. And then xs and ys are going to be things that define the location of the line. We'll talk about those in a little bit. So some things to note. So phi, so phi is assumed to be in degrees. X and y are assumed to be in feet. So if you define, so that that really determines. It depends on how you define your transfer function, right? So this should be in degrees per second. The output of this transfer function should be degrees per second. The output of this transfer function should be feet per second. So if that's not true, then, well, you want to convert, right? You want to put some conversion in here. Whatever units you have, just convert them to degrees and feet before they go in. You've already put in a conversion, right, that goes from phi and rho dot to x dot and y dot. That's just multiplying rho dot by sine and cosine of phi. So you can see here I'm assuming phi is in degrees. That's why I'm converting to radians. Those are integrated to get x and y and phi, right? I have added in these integrators, I've selected an external initial conditions source. That will allow me to put the robot initially at a particular location or angle that's different from 0. So just a little convenience in there. So let's just go ahead and look at running this. So I've created a file that'll help me run it. So I've got some parameters on my controller, my system that I've set here. So I've set here, here's rho dot d, right? So that's this guy. So I'm going to go forward at 0.1 feet per second. I've chosen my initial conditions, right? So those are the blocks. These are these blocks here. Actually set them all to 0 in this case. And then here are those line parameters. So what we've got here is simply a vector of x and y coordinates. So I can plot xs versus ys, and I'll put in markers. And so we can see what I've defined. Actually, I guess it's a little hard to see exactly, but I've got, so I got one point here, another point here, another point here, and another point there. So maybe actually let's add a line to that so we can see how the line goes, right? So I've defined these 4 points. So I'm starting at the origin, I'm going out 3 along x, then I go up to 3, 3, xy, and then over to 10, 3. So this is the line that I want to follow. So my robot's starting at 0, 0, and it's at 0 angle. So it's going to be starting looking along this direction. So it should be following this line, and then it'll turn and then go up. So and you can define a different line, so you can define anything line you want just by changing these numbers, right? So 0, 0 is the location of this point here, and then 3, 0 is the location of this point, 6, 3 is the location of this point, right? So you can change it, and then you can have a shorter or longer line, a more complicated line, whatever you want. So then we're just going to simulate this block diagram. The results are going to come off in this position vector, and then we can animate that using your animation function later. So let's run this. So we actually get a figure which shows the view that the camera sees as it goes through. So you can see that it's keeping the line at the center of the camera. And so it's noticing if the line is to the left or to the right of the center, and then it's telling the robot to move left or right. Now here I'm running my animation code. I've actually added my line in to my animation code so I can also see that actually. So if you go into animation, I've added here the location of the X and Y coordinates to my plot. And so we can see how the robot is going to maneuver around this trajectory. So how it moves is going to be influenced by your controls. You can see if things are oscillating or if you're getting too far away or too close. So there are some things that can influence the performance. One of the things that could influence the performance is the location at which you are detecting the line. And so let's look at the code that's inside the camera block. And so we can see up here, well, it's just defining what should be, what those inputs are to the block. But we got some things we can change. So here, that show image flow, that graph that shows, if you don't want to see it, you can change that to 0 and things will run a little bit faster. Here we've defined the number of pixels in the horizontal and vertical direction. So if you have a different image size that you're using on your Arduino, you could change that and see how that would affect things. Pixel check is the pixel location where we're looking for the blue line. So it's looking for where the blue line crosses this row. Actually, you can see here. So the row it's looking for is 3D4. So the rows start at the top. Row 0, or row 1 is at the top, and then so we're almost down, close to the bottom. So I could look, higher up by changing this to be a smaller value. In here, I've already put in the parameters for your camera. You could also change the height that the camera is above the floor. So how high that camera is. That'd be another parameter you could change. So making that change. So here we've made the change. We're going to look for the position. We're going to look for where that line is a little bit higher up. So if we run the simulation again, so here we see right where it's looking is farther away now, right? So it's higher up, so it's looking at a point that's farther away from the robot. So that can make things a little more stable, right? So if you're having trouble with stability, you can look farther away, but you're not going to be as accurate. So you can see here we're keeping that line in the middle of the image, but we're not really following the line as well as we might. Now, another thing that can influence the stability of your control system is the update rate at which how fast the camera is giving you updates as to the location of that line. I'll just wait for this to finish. So there it finished. Actually, let's do a quick, we just look at the animation of that real quick. So here you can see, right, it's already starting to turn away because it's looking much farther away down that path. So I can change the update rate of the camera in my simulation by right-clicking and selecting block parameters. And so here is the update rate, the sample time for the camera. So right now it's set to 0.2 seconds. So we're getting 5 updates a second. So we could change that to something else. So maybe we're only getting 2 updates a second. So actually let's go back to our camera. Let's change this back to 4/5 to kind of look closer. And so we can see if that's going to be successful. And actually, I guess let me stop my animation first. Finally, a couple Control C's. Finally got it. So now I'll run this. Oh, yeah, whoops. That's kind of bad, right? So looks like our system's not really stable if our camera update is only once every 2 seconds. So, well, it could be a lot of things that influence that, right? So it could be actually it's kind of fun to look at what the robot was doing. So started out okay. And then now it's trying to turn, but you can see, oh, oscillation, right? Oh, so it's classic instability. So maybe our control system wasn't fast enough in our control loop. We're not controlling angle well enough, or we're looking too close, right? So maybe we need to look farther away from the robot, or we need to speed up our camera, right? So there's different things that you could do to try to fix that. So hopefully this will give you a tool to be able to do some tuning of your control system and your tuning of your camera system without actually having to run the robot, right? You can just do this all in simulation, and so that things become a lot easier when you can do things in simulation.